Depth of education, let us continue with ionic chemistry and qualitative analysis. We have already seen how to deal with heating of a substance under test. Then we also saw preparation of solutions of substances under test, so that we can use now reagents since we are done with the heating. So let us now go straight to the use of reagents to determine the cations and anions that may be present in substances under test. So if we have our solution ready, then we can go to detection of ions in solutions. If I have already prepared a solution of a substance under test, which now contains the free ions, because we say that the rationale of preparing a solution is to get free ions which responds readily to the reagents. So, if we have the ions in solutions ready and they are free, then how best can we detect them using the reagents? So let us start with it. Number one, detection of cations. Detection of cations. So, remember the cations that we saw, which are 9 in number, that is calcium ion, magnesium ion, zinc ion, aluminum ion, lead 2 ion, ammonium ion, copper 2 ion, iron 2 ion, and then iron 3 ion. These are the 9 cations. So, when we are detecting cations, then there are some specific reagents that we use in this case. That is it. Cations are detected in solutions using 2 major or chief reagents. And these reagents are: 1, we have sodium hydroxide solution. We have sodium hydroxide solution. And then 2, we have ammonia solution. And this ammonia solution, sometimes we call it, and it is correct, we call it aqueous ammonia. Ammonia which has been dissolved in water. That is ammonia solution or aqueous ammonia. So, these are the 2 major reagents that we use for detecting cations in solutions. So, let us look at the test instruction or test procedure in this case. The test procedure, it says for both of them, in this case for both sodium hydroxide solution and ammonia solution, we need to know how to use these 2 reagents here, and the test instructions are always the same. So we shall say in this case to 1 cubic centimeter of the solution under test, add the reagent solution dropwise until in excess. I want to add something here. If no precipitate forms, then you will be asked to heat the mixture and test for ammonia. So, to 1 cubic centimeter of the solution under test, a 1 cubic centimeter amount of the solution, or this volume of the solution, it is like an equivalent to a 1 cubic centimeter length in a test tube. It is a 1 centimeter length, equivalent to 1 centimeter length in a test tube. That's the same as 1 cubic centimeter. Meaning that do not use too much of the solution under test. Just only something small like 1 centimeter. The length should be like 1 centimeter. So it will be able to respond very fast to reagent. Then we are supposed to add the reagent solution, which can now be our sodium hydroxide solution or our aqueous ammonia. We add it dropwise until in excess. Oh, there's a very serious instruction here that we add dropwise until in excess. So, a candidate in this case understands that he or she is supposed to add it drop by drop until it becomes in excess. So, when will you know that it's already in excess? And for how long will you drop this? We add dropwise until in excess. So, for how long shall we drop? Until it becomes in excess. So, in this case, we are supposed to devise other means that will make us do this test here as fast as possible. So, firstly, add 1 to 3 drops of the reagent solution, and then later on add a lot at once. So we have a reason for doing this one here. This one summarizes this instruction here. Add dropwise until in excess. So we can firstly add some 1 to 3 drops of the reagent solution. This one here is to see if a reagent, if a precipitate forms. This one is to see if a precipitate forms. And then you take note of the color of the precipitate, which can be white. If it is white in color, then we know there is the first 5 cations, that is calcium ion, magnesium ion, zinc ion, aluminum ion, lead 2 ion. So let us first leave ammonium ion aside. The first 5 cations in my list, or in that order, the first 5 cations: calcium ion, magnesium ion, zinc ion, aluminum ion, lead 2 ion. They will give us a white precipitate. If it is copper 2 ion, strictly it will give us a blue precipitate. This now where we are coming to. So if it is iron 2 ion, it will strictly give us a green precipitate. If it is iron 3 ion, it will strictly give us a brown precipitate. Remember, copper 2 ion comes in a green solution, which is a preliminary test when you have just prepared a solution, either by dissolving in water or by maybe dissolving in an acid. So, That one is for copper 2 ion. It will strictly be a blue precipitate. So in this test, you will firstly add just a few drops, like 1 to 3 drops, tack, 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 using a dropper. And you see if a precipitate forms. Then add a lot at once. This now adding in real excess. It is to see if the precipitate can dissolve. So this test is supposed to take a candidate only 5 seconds. Firstly, 1, 2, 3. See very fast, and then you shake a lot, and you add a lot at once. Squeeze your dropper and then you shake. If it does not dissolve, please confirm. If it cannot dissolve, add more reagent solution and you add a lot as you shake. It may dissolve or it may not dissolve. But if it fails to dissolve, then you must have confirmed that it cannot dissolve. Really, it has failed to dissolve, because sometimes it may dissolve. So the test procedure in this case for either one of these two is to add the reagent solution dropwise until in excess. So I say that for the sake of simplicity and time management in this case, you add 1 to 3 drops very fast, and that one is to see if a precipitate forms whose color you take note of, because you will record it, and then you add a lot more at once. It is to see if the precipitate can dissolve. So when you do this one here, you will have already fulfilled this, that you add the reagent solution dropwise until in excess. Now we have something special here, that in case the precipitate fails to, in case no precipitate forms, let us leave this one here. In case no precipitate forms in this case, then the instruction will go ahead and say that then you heat the mixture. So when you heat the mixture, then you need to test for ammonia, because this one is a test for ammonium ion, in that when you add this reagent solution, more especially with sodium hydroxide solution, if you add it dropwise until in excess and you make no observable change, the instruction will go ahead and say that you heat the mixture. So when you heat the mixture, be ready to test for ammonia, because there is a reaction that will take place, and then when you heat the mixture which is formed, then ammonia gas will be produced, of which it will be very simple to detect using the smell, that characteristic choking, irritating smell. You'll be able to get it, and you'll be able to see that moist red litmus paper turning to blue, because it is an alkaline gas. So that's what we shall do. So the instruction will be there for a candidate. You don't have to bother yourself, but be always conscious that in case the instruction goes ahead that you heat the mixture after adding the reagent solution, more especially sodium hydroxide solution, you add dropwise until in excess and you heat, then you just know that they may be driving you towards testing for ammonium ion, because that reaction will lead to the formation of a substance which, when heated, ammonia gas will be evolved out of it. So take note of that. Now, we are going to see how the different cations now respond when we add the reagent solution dropwise until in excess. So we said that what we need to do to simplify our work, we are supposed to just firstly add 1 to 3 drops very fast of the reagent solution. Then we add a lot at once to see whether it can dissolve or not. As simple as that. So let us look at our expected observations. Before this one is a general outlook. A general look at this test here, so that when we go to the nitty-gritties of the tests here, we shall find when we already know what we are supposed to do and what we expect to find. So one of the tests that you will expect to get is a precipitate of a given color, the color you will put it here, which is soluble in excess to form a solution of a given color. Also, let me use a dash here, and another dash is supposed to be here, because this one will now be they will be for the colors of the solution. So, a precipitate of a given color, soluble in excess to form a solution of a given color as well. So, you should be able to get this. A precipitate can form from here, then when you add a lot at once, when it dissolves, then you'll say your observation will be a precipitate, whereby the stands for color. A can be blue, can be white, can be green, can be brown, precipitate, and if it dissolves, the solid particles dissolve and form a solution, then you say it is soluble. And when it is soluble, please, what accompanies it immediately should be the color of the solution formed. That means a candidate should be very keen. Check through that mixture whether some solid particles have remained or not. If it is clear without any solid particle remaining, then you know that it is soluble. And please don't forget to shake in order for the solution of the reagent to mix with the solution under test. Shake a little to mix them so that the reaction takes place. So this is just but one of the expected observations. You may also get a precipitate of a certain color which you don't know,